Hello, everyone, and welcome back to your channel of Engineering and Math Made Easy. Today, we are going to discuss how to find the area between two curves, and that would be an introduction to finding areas of surfaces of revolution and volumes when you generate or when you rotate uh, plane figures around a particular axis. So, as an introduction, again, you learn how to find the area between a curve and the x-axis, right? So basically, it's a very simple extension. It's not anything new that you don't know. There's nothing I will, oops, what did I have? Uh, where's this blue pencil? I had it here a second ago. Uh, okay, doesn't matter. I can use this one now. Okay, so areas between two curves. Suppose I have two curves and one of them is f of x, one of them is g of x, and they look something, I mean, they don't have to intersect at the origin, but just let's introduce something like that. Okay, so this is f of x and this is g of x. And I want to find the area between them. I learned how to find the area between f of x and the x-axis, right? This whole area. It's the integral from 0 to x, f of x dx. And I learned how to find the area between the g of x and the x-axis. So I subtract that. It's that simple, see, nothing new. However, if I have the same limits of integration, I can easily say this is the integral from 0 to x of f of x minus g of x dx. Instead of doing two integrals, I subtract the functions and I integrate. The only thing I need to know is where they integrate. In this case, it's easy. I can see that with my naked eyes. If not, I solve these two equations and find the 2 points of intersection, right? It's that simple. And that's it. Oh, I heard some of you say, but isn't that the same as the area between the g of x and the y-axis? This area right here, minus the area between f of x and the y-axis? I say yes. In this case, in the first case, I took a vertical strip. When you integrate with respect to x, you take a vertical strip, because the height of this small rectangle is f of x dx, f of x minus g of x, I mean, and the base is dx. And that's what we did here. But if I take a horizontal part, I integrate with respect to y, but I cannot say x2 minus x1, for example. Forget about that. It's just this piece. No, I can take the inverse, meaning I'm solving for x in terms of y. So instead of saying g of y, it would be probably g prime of x, g prime of y minus f prime of y, prime, I mean inverse. Okay? G inverse of y minus f inverse of y dy. You can do that, especially if the equation, if the function is easily inverted, and we'll see maybe an example like that. Okay, so let's take a quick example to see how we proceed, and then, oh my God, I left my coffee. If you don't mind, I'm sorry. Okay, so in this example, let's say f of x equals 16 minus x squared, and g of x is, and 4 minus x is good. Okay. So we know this is a parabola. opening downwards, um, and has its axis of symmetry is the y-axis. We know that, right? Because it doesn't have an x term. And so when you have a function like that, it only has a constant and x squared, you know that the y is the axis of symmetry because we write this as ax squared plus bx plus c, right? A is -1, b is 0, right? And notice that we say axis of symmetry is at x equals negative b over twice a. If b is 0, don't waste your time. We know already that 16 and 0, when x is 0, you get 0 and 16. -4, well, I drew it very far. -4 and 0 and 4 and 0. How do you know? Because 16 minus x squared, that's a perfect square. When you solve, you get x equals plus or minus 4. So we know this is a parabola, horribly drawn, that opens down. And I know the area between the parabola and the x-axis. And then we have 4 minus x, and this is 16 minus x squared. 4 minus x meaning they intersect here, but where do they intersect on the other side? It turns out that, of course, if I want to find the points of intersection, I can have one of three cases. If this line is away, you get no intersection. How do you relate to algebra? Solving a quadratic equation and getting two complex answers. There's no intersection. Intersection is solution. Intersection in geometry or in graph is solution in algebra. How do they get a single? So if this line gets closer and closer and becomes a tangent at a particular point, it doesn't matter which point, it depends on its slope, right? But it just barely touches the parabola. What is that? Two equal solutions when your discriminant equals 0 and you get the answer is negative b over twice a. General case, you intersect at 2 points, negative b over negative b plus or minus square root of b squared minus 4ac. So that's the general solution. This is a unique solution, and that's no solution at all. That's the graph interpretation of algebra. So in order to find the other point of intersection, you equate the two graphs, two equations. We don't want to waste time, so I'm going to move this to the other side so the x squared becomes positive. So I get x squared. This stays here, so minus x. I have 4 minus 16 is negative 12. I can factor as x plus 4. I already know that. I already know x minus 4, I'm sorry, because that solves for x equals 4 times x plus 3. So I get either x equals 4 or x equals -3. Notice I don't care about the value of y because I'm not using that anywhere in my integration. My integral now to find the area between the two graphs is to take the integral from -3 to +4 of the top function minus the bottom function, which would be the opposite of what we did. Notice when we move this to the other side, is the same as saying g of x minus f of x, right? Do you see that? I moved it so that I end up with a positive uh, x squared, so it's easier to factor. So, but by moving that, I said g of x minus f of x. Here, I want to do the opposite. So instead of writing 16 minus x squared minus 4, you already have it here. It's negative x squared plus x plus 12 dx. Again, it doesn't harm to subtract them, but you already have that. Next step, I do the integral negative x cubed over 3 plus x squared over 2 plus 12x evaluated from negative 3 to 4. Please be very careful of what you are doing here. I've seen too many mistakes for students. So the way I always do it, and I tells always tell you to do that, is to have two pairs of parentheses with the negatives. In fact, even if you follow the video about determinants to find the determine 2D or I'm sorry, two dimension or three dimension determinants of matrices that are 2 by 2 or 3 by 3, I ask you to form two pairs of parentheses with a negative sign between them. It's always safer, and still you can get errors, so be very careful. We are substituting the value of x. So every time you see an x, you write a 4. So here I have a negative that doesn't affect anything. Then I have 4 cubed, which is 64 thirds, plus 4 square, which is 16 halves, 8, plus 4 times 12. When you come here, that's where you have to be careful. First of all, I have a negative sign, but then the x is negative 3. So you have negative 3 cubed. Negative 3 cubed is negative 27, and I have a negative outside. Notice we have three negatives here. There is a negative between the two parentheses. There is a negative that was a result of the integration, and another negative that is 27 over 3. So I can cancel this is negative times negative is positive, so I can transform them into positive without a problem. Negative 3 squared is positive 9, so I don't have a problem here. And negative 3 would make that negative 36. Then take it one step at a time. 8 and 48 is 56 minus 64 thirds minus. Here I have 9 plus 9, well, let's write it 9 plus 9 halves minus 36 equals. I have 56 minus 64. It doesn't matter if you take an extra step, just to guarantee you are doing it correctly. Minus 9 halves plus 36. Now I can combine the constants together. 56 and 36 is 92. Minus 9 is 83. I have halves and thirds, so let's keep them for now. Well, as I said, you can use the calculator. You don't have to do all of that. But if you want to show your work, here you have a 2 and a 3, so you take a common denominator of 6. 6 times that is 498. 2 times that is 128, so a difference of 370. And 3 times 9 is 27. 370 minus 27 is 343 over 6 square units. Yes, you can use, of course, you could have done that with your calculator right away. In fact, you can take the area under the curve of f of x and subtract the area of under the curve of g of x. So do two integrals on your calculator and see if you get that. If you get it, of course, you will get, when you subtract, you will end up with a decimal place. So just transform it into a fraction and check that. Okay. Let's move to another example. I want to show you, let's see, do we have a nice one? I want to show you if, oh yeah, here's the pencil. I found it. Okay. So this example from some sites, it says f of x, and I like this one because it's gonna illustrate what I wanted to show you. Find the area of the region. F of x equals x squared. And g of x, well, that's similar to what we did, but 2 minus x. Yeah, it's almost the same, but there is a point here that I wanted to make. So maybe that problem will take a little longer, but it's important that you understand it. The x, the y, again, x squared. Okay, so it passes through the origin. And again, the y-axis is the axis of symmetry because we don't have an x term. 2 minus x, we already have done that. So if we take 2 and 2, 45 degrees. Oh, but here, they want you to find the area, this area. That's what I wanted to tell you. It's a little trickier than before. I don't want the area between the two curves. This is exactly the example we did. But now I want to find the area between these two shapes. Okay? Now, of course, you can think of, should I integrate with respect to x or with respect to y? First, let's find the points of intersection. This point is 0 and 0. This point is 2 and 0. You don't need math to do that. And then you would find the point of intersection. In fact, there are 2 points, but I don't care about that one. I want this point of intersection. So I'm going to equate the two graphs. And when you do that, you will get x squared. Move these to the other side. So plus x minus 2 equals 0. So you get x plus 2 times x minus 1 equals 0. X equals -2 is this guy. I don't care about it. But here, x is 1. And if x is 1, then y also is 1. When you square 1 to get the y, you get 1. When you subtract 1 from 2 to get the y, you get 1. So 1 and 1. Give you a second to think about it, and then tell me how you are going to solve it. So you can pause the video and come back. Okay, what do you think? Should I integrate with respect to x or with respect to y? I should have drawn it larger so you can see. Okay, of course we are not on air, so you are watching that that video like later. So I'm going to tell you there are two ways. One is easy, one is hard. Which one is easier? With respect to y. Why? No, I'm not repeating. I'm asking why. Okay. Notice that if I take a horizontal strip, the width of this horizontal strip is the y at this on this line minus the y on this graph. And you would say, how do I get that? So easy. I can find the y here by saying the x, notice x squared equals, let's write it x squared equals y, meaning x equals root of y. Notice I don't have anything below the x-axis, so there is no reason to say plus or minus. It's just root y. So this is root y. How about this? Well, that's easy. So x is 2 minus y. Notice the one on the right is 2 minus y. The one on the left is root y. And the height is dy. So the area equals the integral. I'm going for y equals 0, which is the x-axis, to y equals 1. Right? Y equals 1. Of what? Of 2 minus y minus square root of y dy. You see how we transform from x to y? You have to do it because you are integrating with respect to y. I cannot say x, what is x squared dy? Yeah, there is, but I don't know. It's not easy for me to see. I have to transform, okay? So you get the integral as 2y minus y squared over 2 minus, this is y to the 1/2, so you get 1 to the 3/2 divided by 3/2, meaning multiplying by 2/3. Lucky because the integral is from 0 to 1, and 0 will yield 0, so you don't even need to do two pairs of parentheses. You just say 2 minus 1/2 minus 2/3. So easy, right? Notice, here we can take, again, like the previous problem, same thing. You take the denominator of 6. 6 times 2 is 12, minus 3, minus 4. 6 over 3 is 2 times 2 is 4. 12 minus 7 is 5. 5, 6 square units. 0.8333. Done. Move to a third. Now, I'm going to stay with this example. I'm not moving. I'm going to say, I'm going to do it with respect to x. Why? Because I like to torture you. Oh, sorry. I'm sorry. Of course. They are going to unsubscribe now. That was the worst thing I could say. No, I want to show you that, yes, you can make it hard on yourself, but to check to see if it's really 5, 6, did we do it correctly? Can we like corroborate our answer? If I take the integral with respect to x, I have a problem. Which graph? Do you see that I can say it's the area under the parabola from 0 to 1 plus the area under the straight line from 1 to 2? Do you see that? If you see it, then I have a surprise for you. Do you know what surprise it is? Okay. Those of you who were lucky and watched the videos on engineering statics and found how I showed you how to find the area under a second-degree parabola, and I told you it's 1/3 base times height. 1/3, base is 1, height is 1, so this area is 1/3. I know it without integration. And the area of a triangle whose height is 1, this point is 1 and 0, and base is 1 is 1/2. And the area is 1/3 plus 1/2 is 5, 6. How do you like apples? But I don't know that. I don't know the area of a triangle. I'm a very old man. I'm going to do it the way I was learned at school. I'm going to take this strip, which is x squared minus 0, and I'm going to integrate it from 0 to 1. And then I'm going to integrate from 1 to 2 this straight line that says 2 minus x dx. So this will give me x cubed over 3 evaluated from 0 to 1. That will give me 2x minus x squared over 2 evaluated from 1 to 2. This one is easy because at 0 you get 0, you get 1/3. Oh, 1/3. So I guess I didn't have to do this integral. Oh, just to show you that it's really same thing. Plus, now I have integration between 1 and 2, so I would have 2 pairs of parentheses. I would substitute with 2 here. 2x is 4 minus 2, because 2 squared over 2 is 2. And here I have 2 minus 1/2. So at the end of the day, I get 1/3 plus 2 minus 2 minus 1/2 is 3/2, because this is 4/2 minus 3/2. So you get 3/2. Guess what? 2 and where was it? Yeah, 2 and minus 1/2 minus 2/3. Here we have, now we have 1/3 plus 2 minus 3/2. But this guy right here is 1/2, right? 1/3 plus 1/2. 1/3 plus 1/2. And of course, you get 5/6 square units. So really, I can do it with respect to x. I can do it with respect to y. I can do it without integration if that's not a course. If that was like something you are working on and you have something like that, you say, oh, I've seen how to find the area of a second degree parabola. Uh, before I learned how to do it very easily and the area of a triangle, so I don't need to integrate. So math is not about you have to follow a specific route. No, you pick the one that works for you, right? If you know something that you learned in another course, but it makes perfect sense and you can remember when we had substitution in integration and we say, oh, we know from trig that 1 minus x square, I can transform it into 1 minus sine square or 1 minus cosine square. And if there is a root, it makes it easier to use trig transformations. So math is all related. Like I told you in this example, you know, this means when I solve the quadratic equation, I know beforehand I will have two distinct answers. If that was a horizontal line that is y equals 16, I know that I will have a single solution. And if that was above the parabola, these are two complex answers, right? So it's really, just everything connects with everything else. I don't know if this is enough. I think that's enough for now. If you have, any questions or a problem that seems hard for you, you can, let me know about the functions in the comment section, and maybe we'll have another session about that. Thanks for your time, and I wish you all the best.